Hey everyone, welcome back to the Joe Rogan podcast. We're on episode 2405. Today we're diving into the world of chemistry and ethics with two, let's just say, unusual guests. We have Wilhelm Ostwald, legendary chemist, and well, the mole itself. Yeah, you heard that right. Today we're getting a mole's eye view on the impact the scientific concept has brought across different fields. So welcome to the show, Wilhelm and Mr. Mole.
Thanks, Joe. It's about time I got a voice in this whole chemistry business. For centuries, people have been talking about me, measuring me, and using me, but they never stop to think about my side of things. It's always how many moles and never how are you, mole?
It's good to be here as well, Joe. I spent years thinking about how to make complex chemical reactions clearer for scientists. And that's how the mole concept came to life. It's nice to finally chat about it on such a platform.
Great. So let's jump right in. Wilhelm, take us back to the beginning. How did you first come up with the idea for the mole?
Joe, so it all started with the need to bridge the gap between atoms, tiny, invisible things, and real world quantities we can see and measure. Chemists needed a way to talk about these minuscule particles on a practical scale, and the mole was born to address that. I wanted to provide a constant, reliable way to link these worlds together, and over time, it became the backbone of chemical measurements.
I became a universal translator, you could say. Suddenly, I was the link between the microscopic and the macroscopic. People could measure substances and reactions accurately, all thanks to me.
That's interesting, Mole. So, Wilhelm, when you invented this concept, did you anticipate how widely it would spread?
I had no idea it would become so embedded in daily life. Think about it: medicine, environmental science, food, even pollution control. It's everywhere. People are using the mold to ensure safety, quality, and accuracy. Just imagine calculating drug doses for patients without the mole concept. It would be chaos. And as it spread, so did its applications, often in areas we couldn't have foreseen. As my colleague Swante Arrhenius once said, the goal of science is to understand the world around us, and the mole helps us to do that.
Speaking of applications, let's talk about some examples, shall we? Mole, how do you feel about being used in all of these different fields, especially things like medicine and food safety?
Honestly, Joe, I feel a bit of a burden sometimes. In pharmaceuticals, for instance, my role is crucial. Doctors and chemists depend on precise measurements to make sure patients get the right dosage. A little too much or too little can have serious consequences. It's a heavy responsibility to bear, but I know I'm saving lives. Then there's food safety. People need accurate ingredient measurements for health and nutrition standards. Without me, we'd have some pretty chaotic grocery shelves.
Absolutely. And that brings us to the ethical side of things. Wilhelm, do you ever think about the ethical implications of your work back then? I mean, you were making it easier to handle chemicals, but now this concept is tied to real life health decisions.
It's true, Joe. But back then, my focus was purely scientific, on solving a problem. But now, seeing how the mole is applied to real world ethics is eye opening. When you're dealing with accurate dosages or pollutant measurements, it's not just science, it's a responsibility. Today's chemists and scientists have a duty to make precise calculations, knowing that people's lives, health, and the environment are at stake.
And from my point of view, Joe, I'm just as bound to those responsibilities. Whether it's ensuring the right dosage in medicine or calculating pollutant levels, the ethical aspect of using me correctly is huge. If someone misuses the mole or ignores its importance, there could be real harm done.
Right. Let's dig a bit deeper, shall we? How does the mole concept influence practices in environmental chemistry?
Well, Joe, in environmental science, it's all about quantifying the pollutants we're exposed to. When scientists calculate the concentration of harmful substances, they're using the mole concept. It lets us know how much of a pollutant is present, say in the river or the air we breathe. These calculations are vital to setting safe exposure limits, understanding ecological impacts, and even creating policies around pollution control.
Exactly. And Joe, it's not just about the numbers, it's about accountability. The mole concept ensures that we're measuring pollutants accurately, which means people are protected. It's a constant reminder of the ethical duty to get it right.
So, last question before we wrap it up. With everything we've talked about today, what advice would you give to young scientists and chemists when it comes to using the mole concept responsibly?
I'd say don't take me for granted. Every calculation counts. When you're in a lab or on a research team, think about the people relying on those results. Don't cut corners and make sure you're applying the mole concept with respect and accuracy.
And for me, I'd remind everyone that science isn't isolated from ethics. Every tool, every calculation carries weight, whether it's protecting the environment, ensuring patient safety, or meeting food standards. Our work as scientists is fundamentally about trust. Remember that and use these concepts wisely.
Well, that's some serious wisdom. Thank you, Mol and Wilhelm, for joining us and giving us a whole new perspective on something we often take for granted. Understanding the mole concept has given us insight not just into science, but also into the responsibilities we carry. All right, folks, thanks for tuning in. Stay curious, stay ethical, and remember, science is more than just about numbers. Until next time.
Preview.